Welcome, book lovers. We're talking more books today. We're going to get into a book about the ever shifting body of knowledge known as science, and how facts change over time. It's an interesting subject, and it's something we see actually quite a bit. We've seen studies change. We've seen studies show this, and then later studies show the opposite. And we learn more as the more studies are done. That's how science works. It's a little sloppy, it's a little messy, and these are the top 10 things that I learned from the half-life of facts, why everything we know has an expiration date. Number one, scientific knowledge is like radioactivity. It has a half-life. Now, half-lives are most famously in the Schrodinger's cat experiment, where you have some radioactive substance, and if it decays, then the cat dies, and if it lives, or if it doesn't decay, then the cat lives. And that's half of it. Like a half-life. If it has an 8-year half-life, then it takes 8 years for half of that substance to decay. And it's just based on averages. The rate is, some are decaying immediately, some aren't, but overall it's all based on averages. Number two, in 1912, cell nuclei were first visualized, and 48 chromosomes were counted in humans. Now, that wasn't surprising because we know that our primate relatives also have 48 chromosomes. Chimpanzees, bonobos, great apes, all of them, orangutans, everybody's got 48 chromosomes. So this was really no big surprise that humans had 48 chromosomes. And that was first published in the scientific literature in 1912. All the way back then, we knew we were counting chromosomes, which brings us to point number three. Turns out that was wrong, because in 1956, two biologists counted 46 chromosomes in humans. And that was a little bit of a shock, because why do we have, if we're descended from primates, then why do we have less chromosomes? And turns out there is evidence of fusion. The chromosomes fused for mysterious reasons. To my knowledge, that doesn't normally happen. Chromosomes, as they accumulate more and more knowledge, they split. Fusion is, from what I understand, unique to this situation. Nonetheless, that was 44 years later. So it took 44 years for us to figure out that actually humans have 46 chromosomes. So there is a perfect example of facts changing. Number four, there are variable rates of change with facts, and these are discussed throughout the book. It's a fascinating book. I stumbled across it in the bookstore. I hadn't heard of it before, and thumbed through it, and I fell in love. I was like, I'm taking this home. I didn't plan on buying this book, but you're going home with me, babe. And read it, enjoyed it, and it is all about the different ways of quantifying our accumulation of knowledge. And he has a lot of charts and graphs showing you these variable rates of change with various fields and with various technology and whatnot. Brings us to number five. It takes 50 years to get a wrong idea out of medicine and 100 years to get a right one into medicine. So says John Hewlings Jackson. That is a quote by him that appears in this book, and it is the rate of change in the field of medicine. It takes about 50 years. Turns out that quote, he was speaking with approximations, and but when the numbers were crunched, medicine turned out to be 50 years to about 50 years for the half-life of facts in that field. So that means every 50 years, half that information that was current when it was taught is expired, is invalid, is no bueno. That brings us to number 6. The quantitative measurement of the development of science is known as scientometrics. I love neologisms, and the word scientometrics, I was like, I've never heard of that before. But that is what this field is. They don't call it the half-life of facts. They call it scientometrics, and it's a relatively new field. It's a branch off of mathematics, and it's also discussed thoroughly in this book. They get into Moore's law, which isn't really a law. It's kind of a marketing scheme, to be honest. And it has recently been debunked. Moore's law isn't holding fast anymore. I don't think that was known at the time of the publication of this book, but nonetheless, that is what it is. Number 7, Derek Price estimated the amount of time it takes to double knowledge in a field, and those charts are published in there. And that he kind of he came up with this idea. I guess they were doing something at the library, and so all the professors were taking home parts of the library so they could refurbish it or something like that. And he was noticing that the scientific journals that he had, each year he noticed the pattern. He noticed that each year of these journals, they were roughly corresponding to doubling in knowledge. And he was like, oh, that's mathematics. That's something I can look into. And he started looking into it, and it was different rates for different fields, and those are in the book, and some of them are in this video as well as screenshots. Pictures I took. Number 8, website bot filters are actually helping to digitize unreadable text, such as the New York Times archive. They were talking about citizen science in the book, how people that were playing this game, and the game actually was not a game, it was folding proteins. They were doing like genetic research, and so all these people, while they were playing the game, they were actually solving the complexities of protein folding. And that's also what's going on when you get to a website and it says, read this, type in the words of this text. That's unreadable text. And by you typing it in for them, it goes into the archive. Number 9, more than a third of all animals that went extinct in the last 500 years have been discovered alive. That's pretty fascinating, and that's very hopeful, because we have lost in the last 500 years quite a lot of animals, and it's getting worse all the time due to mainly overpopulation. Like, regardless of what anyone else says, whether they're going to say climate change or pollution, it's really overpopulation. That is the underlying problem that we are facing with that. But it is hopeful to know that things like the dodo and the Tasmanian devil, those things have all been cited. So they're out there probably in just very vanishing small numbers, and people frequently underestimate how difficult it is to find some of these creatures in their natural habitats. Number 10, Lazarus taxa represent the rediscovery of extinct creatures such as the coelacanth. That's another neologism that I really like, the Lazarus taxa. Well, I mean, that's not necessarily a new word, but it's taking the Lazarus, the biblical character, and applying him to a scientific taxa of rediscovered creatures. And that happens more frequently than you would think. I mean, it's not, the coelacanth is certainly one of the best known examples, and other examples aren't as famous. Nonetheless, it's an entire taxa. There's a lot of different things in there in addition to the coelacanth, and those are the top 10 things that I learned reading The Half-Life of Facts. An excellent book, and it I think it's timely. I think this guy came up with a brilliant, that's a stroke of brilliance, terming this the half-life of facts, and science is definitely a lot of books that I have talk about this. Like, science is at a crossroads. The old guard is shifting. There is a paradigm shift coming, and a lot of science is not accepted, not because it's not good enough. It's because it is outside the box. And this book is bringing to light the new science. So good on him. Samuel Arbesman, he wrote this, and go check it out. It's at the bookstore, and it's on Amazon. Thanks again for listening.